Hey, what is up, guys? How are you doing? It's Ivan here, and I've been playing around with YOLO version 3 for quite some while actually, and it wasn't hard technically, like it didn't involve that much coding or like anything, super hard, but it required me to figure out lots and lots of details on how to, get it all up and going, how to compute anchors, how to prepare the training dataset, how to run YOLO in Python, and with the help of super kind and awesome people from Twitter, I was able to figure it out and like get it all going. And now I'm super excited to share with you this series, and I hope that it will help you to go through this process, faster than I did, and I hope that it will bring you some value and accelerate your YOLO progress. Because YOLO is super like YOLO is awesome. That's all I can say. Okay, so what you can expect from this series, like what I'm gonna tell you here. Actually, I'm gonna like tell you everything that I've learned, which is how to run YOLO in Python with OpenCV. Then, and that's like the coolest part, how to train your own custom model. I'm gonna show you how to label all the data, how to, modify all the CFG files, how to, set it all up to train in Darknet. And of course, I'm gonna show you how to install Darknet on your Windows machine, and like the steps are pretty similar for Linux. In fact, they are actually much easier, I would say. And then, I'm going to show how to label your data. For instance, here I trained a model to detect opened and closed bus doors using like only 390 bus images from Google, and like some noise images here and there. And like here's what I've got. As you can see, like the model detects the doors like pretty good. Not perfect, because clearly these doors are closed, like, but we can forgive it for that, because like there wasn't that many training images there. But yeah, I'm gonna show you how to train your own model, and like the coolest thing that I discovered the last that even allowed me to train it all in the first place, which is how to set up YOLO on GoogleColab, which is, for those of you who don't know, GoogleColab is a super awesome thing. It's a web hosted by Google Jupyter notebook that allows you to run your code there. It's a Linux and only Linux Ubuntu operating system. And like the most mind-blowing part there is that they give you a free GPU. Like, for real, not just any GPU. They give you NVIDIA Test like A80, which is a several $1,000 GPU for you to use and train your models, if you're willing to eat some dirt and figure it all out, which is not that hard. So I'm going to show you how to do that. So we'll learn how to run it all in Python, how to prepare your training dataset and train your custom models, and then I'm going to show you how to run it all in Colab. So where by the way, in Colab is where I processed this video just a few moments ago, and you can see it run here with like 14 to 15 FPS per second, which is, let me tell you, is a heck of a lot faster than 0.3 FPS on my CPU. So yep, let's get started, guys. Let's get started. So guys, just before we get to code, I just wanted to like clarify a few things and just explain what's going on here. Okay, so what is YOLO? YOLO stands for You Only Look Once, which is like, YOLO is a convolutional neural network. The name stands for You Only Look Once. Why? Because it only looks once at the image, it only does one, evaluation process of the neural network to get the results. instead of like the previous method that used sliding windows that would slide across the image using classifiers everywhere to kind of try and detect something, which was long, and like you can guess that because you gotta slide, you gotta each step you gotta evaluate it and propagate it, and all of that was long and not really effective. Plus, YOLO looks at the whole picture, so it also pays attention to context, which is also improves its accuracy, and it's like one of the reasons that makes it the state-of-the-art object detection neural network, at least like at this moment, uh, like to my best information that I know. So, and if you want to learn more about it, YOLO is completely open source, thanks to Joseph Redmond, the guy who's created this whole thing. So you can like go on to the official YOLO website. The papers are open source, so you can like go and read them. Neural networks architecture, its loss function, the grid cell, like all that stuff is explained there. And also there are some great videos on YouTube on that. Suresh has a pretty good video explaining how YOLO works, and Joseph Redmond, the guy who's created the whole thing, also has done 2 TED Talks, so I recommend you to check them out. So, now let's get to YOLO. So what are we gonna need to run it in Python? And we're gonna need this. So first of all, when you go to the official website, you can see that like there's like a bunch of YOLOs. We're interested in those guys and these guys in YOLO version 3 and YOLO version 3 Tiny. What's the difference? You will never guess is that YOLO version 3 Tiny is smaller, and you will never guess again it's faster. So will work for both the big YOLO and the tiny YOLO. So what do we need to run it is that we need to download the model configuration with this CFG file and the weights. Just click here, it'll start downloading the CFG, I think. I'll take you to GitHub. So we'll go there, click roll, and then you're going to need to save it all to the folder that that you need to create here, where we'll like put all the important stuff. So go ahead and like click save as. My browser is in Russian, guys, but bear with me. Trust me on this one. YOLO version 2 with OpenCV, our folder. Just go ahead and save it. So that file already exists. Replace it. Yep. Let's replace it. I mean, you get the idea, right? So download the weights, they will just start downloading. They're about 200 megabytes here and there, and the last thing that you're gonna need is that names file, which you can find on GitHub. I'll leave the links like everywhere, all over the place. Promise. So what's the thing with Coco.names? Basically, this model of YOLO was trained. No, that's not what I was looking for. It's definitely not that. There we go. Was trained on this Coco dataset, common objects in context. So, because it was written there, like, it has 80 objects in it. And the network will fire the neuron, like the certain neurons will fire, like there will be 80 neurons, right? And first, if the 0th neuron fired, then it's person, if the second it's car, and so on. So we're gonna need this file to interpret the number of the neuron that's firing with the corresponding class that it's meaning to predict. So we're gonna need to this guy also go better in the Russian browser. That's typical stuff. So go and save it with that names, put it all here. So basically you'll have weights, have YOLO version CFG, and you'll have Coco.names. So here I've opened my PyCharm in this directory, and so I've already got the program, so I'm gonna look at it from time to time, because, like, trust me guys, you do not wanna see my thinking face. It looks like this. And it's super boring, so like I don't wanna show it from time to time. I'll do pausing the video and looking there. So just go and create an OD file that stands for object detection, or call it like whatever you want, and make sure that you have OpenCV installed, because this code that I'll be showing you will be based on this really awesome article from Learn OpenCV. They have their code for Python and C++, but you know, I simplified it quite a bit so that it'll be easy to kind of go through and explain certain things. But if you want to kind of learn more, so I'll leave a link, go and check it out. So as I said, you're gonna need OpenCV, so you can just go to pip and write pip install OpenCV Python, so you'll get OpenCV or whatever, like whatever is the way you do that. And so let's get started, guys. Let's do that. So guys, I'll get to the code in just one moment, but I've just looked through like all the videos and I realized that like I went like explaining on every single line, so it's gonna take a while. So I thought that it would be a good idea for me to just give you a little demo before the code of like what's gonna happen like when we run YOLO, and then I'm gonna do another one after, just so that maybe, you know, it's easier to kind of, you know, you know what to expect, and you can maybe go through the code a bit easier. And also, like, if the explanation is somewhere confusing, I also encourage you to go to Learn OpenCV website of the article. I leave the link there. Just make sure that you know, get the code, like whatever it takes, and like I'm here to do my best to help. So like, okay, let's like look at the demo. So basically I just went around with the camera a bit. It actually goes like real quick because it's been saved through the Python script. But like if we slow down just a little, here I am with my sports ball, from which I happen to also drink tea or like water, but it usually detects it as the cup. There we go. Here's the banana pile. I was too impatient to do the actual banana, so like there we go, banana pile. So as we can see, it's doing a pretty good job. I mean, this network's just good. Then I was trying to show it the horse. It was thinking that it's cow or duck or cat, dog, like. I don't think I got the horse, but you know, I got the horse, I think, in the last demo that will be in the end of the video. And there you can see some potted plants, books, and me. There we go. So just that's what we're gonna get. We're gonna like draw manually all the rectangles and all the labels, except like that's the version from the Learn OpenCV, and our is gonna be pretty much the same, though a little bit just less fancy with the, you know, label. This is like all the simple stuff. We're here for the neural net, so like we'll get to it. So okay, now let's actually jump into the code. So okay guys, thanks for bearing with me through all that so much. Now we're finally getting to the meat, to the core of like what's gonna happen here, and let's get to code. So like we'll make OpenCV read, you know, Python files and run them with the webcam. So, or you know, you can like save stuff as videos with OpenCV. You can do whatever you want with them. We're gonna get files, we're gonna get labels. So let's start. So first of all, we'll import CV2 as CV, it's OpenCV, and we're going to need to import numpy as np. And we're going to have to specify a few variables that will, you know, essentially tell our network how to work. So this will be confidence threshold, And the counter is like when YOLO runs itself, it will essentially put a bunch of bounding boxes like all over the place. It'll like think that my hand is a cell phone and my nose is a banana, but with like real low confidences if it works well. So by setting up this confidence threshold, we're essentially will be telling YOLO, hey dude, like if you're not that sure that the prediction is correct, like don't show it, just keep it down, just don't do that. So if you're like less than 20% sure that you're predicting something right, just keep it to yourself, man. We don't need to see that. Or if you're like training your own custom model running here, you can set your threshold with like 0.05 if like it's not that accurate and you just want to see something. Help me with my not so accurate model that I've trained. So then there's maximum suppression threshold, and we'll essentially need that thing to kind of optimize the output of the network. We'll get that a bit later. Just bear with me here. So the input width is 416 and in height is 416. This will be the resolution to which we'll be reshaping our OpenCV input so that it can be suitable for the so that it'll be suitable as a YOLO input. That's it. So now we'll specify what's our classes file and what is our classes file. Guys, tell me if your memory is good, or you can also look at the right side of the screen just as I can. Well, let's go code the names. And yep, in classes we'll set none for now. So now we'll open this classes file in the RG mode, and that will essentially read it in a way that leaves us with a list of those classes, so that we can basically match the index of a class on a list with its name, like the zeroth neuron is firing, which means that it's like the zeroth item on the list, like on this Coco names list now, and which is like a person. So we're basically do that here. So now model configuration, we're essentially gonna have to specify the YOLO version 3.cvg, the configuration file here, and our weights that we've downloaded. So alright guys, now that we've specified the configurations, like now it's time to set up some OpenCV stuff. Namely, let's name our window as deep learning object detection with OpenCV, and then we're gonna create then we're gonna name the window that. And window will name cv.window normal. Then we're gonna resize this window so that it's gonna be a little bit bigger than 416 by 416. It's really easy to do here. Really easy. Resize window. Specify the window's name. Window's name. And 1000. We'll make it 1000 by 1000. So, and then we're gonna have to specify the capture, basically from where CPU will be taking the video input to process. And like what this line of code basically does is it says it like go and use the webcam as the source of video, and I've put 0 there. Basically, like if you have just one webcam, you put 0. It means the first webcam. If you have several, you may need to put there like 1 or 3, or if you're like a really big webcam guy, guys. If you're like really into webcams, but I'll go with 0. So now we'll, you know, put together the skeleton of what's gonna happen here. So while true has frame and frame for capture that we read. So now that we've done that, we can go up once again and let's set up the neural net. We'll say that net will be cv.deep neural networks, and we'll call here read net from Darknet, which is just what we want, and we'll put here our model CVG file and our model weights. Model weights. So, and we'll set the preferable back end, which is like in which format do we want the network to like output its stuff. We'll say, of course, use OpenCV. Of course, use that. And set preferable target. I think there's only for now I think you can only process OpenCV on your CPU here, so we'll say that our target is CPU. So now we've got our net in place, so we can go here, and now we're gonna have to, like, remember when we were specifying the input width and the input height of the image, we were basically doing that so that we can reshape it then, and not just reshape it, we need to turn it into a blob, into a 4D blob image. Which, like, I'm gonna explain what's gonna happen here, just let me type it out. Okay, there we go, guys. So what's going on here? So in order to use our image as an input for a neural network, we gotta create the blob image. So what we're saying here, take our frame, then rescale each pixel, basically multiply each pixel by 1/255, which is like the colors in the array of the image. So basically, you know, like they're from 0 to 255. We were basically saying turn the colors in the image into percentages, into the percentage values, if I can say that. After that, go and rescale the image, and then this thing here, this tuple stands for the mean subtraction, basically whether you wanna subtract some colors from each pixel, and we put all the zeros there because we wanna keep image as it is, and it makes sense. God, I forgot what this one stands for here, but okay, guys. So I went back and like researched a few things really quickly, and this one basically stands for, it's the default parameter of, you know, up here. We want to keep the swap RB parameter to its default value of 1. Swap RB, it's the color stuff, and we're definitely not gonna crop our image, just you know, resize it, so we keep crop as false. So then we set our input to the network. We'll give it the blob, big, binary large object, and we'll get our outputs from net.forward.getOut out names, the function will define in a moment, and post process frame out will also define that really soon, guys. Frame. And then we'll show our results. So we've got 2 functions to define, and actually like 3 functions to define. So okay guys, we're getting there. We're definitely getting there. So we've got like the frame that we're getting from the webcam, we've got the blob, the the resized input for the network, and we give network this input, and then we need to forward the we need to like run the network with this input, and we have to specify here the names of the output layers in the network from which we kind of want to compute and take the outputs. And like I'll probably like put a window here of like what I did is like printed out those guys here, so you'll see that YOLO network in the CFG file has got like 3 YOLO layers where like it kind of outputs things. And if you're gonna be sticking around like in training your model, you're like gonna know that, because I need to modify the classes and filters there. But like there are 3 YOLO output layers, and you have to give it to network so that we can properly compute the output, and we do that by writing this code here. First of all, we get all the layers in the network, and by running this code we get all the unconnected layers in the network, aka the output layers. So there we go. Now, okay, that was like the boring kind of stuff. Like, let's be honest, now let's get to the fun stuff. Let's finally work with the outputs of the network. So YOLO outputs is a, I think it's a like 4D or 3D tensor. And okay, let me just open this thing here. Let's define process framing outputs. So yeah, okay, so basically YOLO outputs like that tensor where it's got like this grid cell where it predicts stuff, and basically each grid cell's got a number of like vectors in it, where the size of the vector is like 85 for each object, where the first 5 guys there are the x of the center, like the x of the center and the y of the center, and then there are width and height of the bounding box that we're reading there, and the like other 80 guys are the classes. So that's what I was like talking about, like if the 11th neuron there is firing, then like it's the 11th or like probably 10th, maybe 11th, I don't know, index, index from that list. And it also outputs the center, like the x of the center and the y of the center, and then there are width and height of the bounding box that we're reading there, and the like other 80 guys are the classes. So that's what I was like talking about, like if the 11th neuron there is firing, then like it's the 11th or like probably 10th, maybe 11th, I don't know, index, index from that list. And it also outputs the center, and it outputs the centers in percents. In percentages like 0.5 and x in like 0.6. Why? So we'll define here the frame height, so that we can then multiply it by the percentage and get the pixel value that we want. Then we're gonna define the class IDs list, our list of confidences, and boxes. And this thing here is not important, it's just if you want to pull out the results, then you can do that on your own if you like. Get the basics of what's going on here. And again, you can go and read the article is also great if you like wanna add a few nice features here. So for output in our outputs, so this thing will return, you know, like that tensor, and then we're gonna go through each vector in that tensor. So it's going to be for detection, in the output. So we're going to define the scores, which is like the first 5 guys, the centers and width, height, and the confidence. And then we're gonna go and argmax the scores. Okay, no, forget like what I've said before. Scores are the other 80, you know, if we print this thing out, we'll get 85, which like the basically vector of like 85 values, and the scores will be like all the guys other than the first 5, which, you know, define what's going on there. Which, you know, give us the centers and the width and the height. So like that's what those guys are gonna give us scores. So we use the NumPy argmax, we'll basically look at that vector of 80 objects and pick out from there the biggest one, so that, you know, like whether that, you know, part of the grid cell predicts something feasible or not. So like that's what it's gonna do. Like, yeah, I know it's kind of messy, and like, but I really hope that you're just as excited as I were when I was figuring it all out, and like that you will be willing to go through the, you know, boring stuff here and there. Of course, and we'll take, like, we get that class ID from there, which is like the number of that element, and that thing will basically be like from, you know, from 0 to 1, like the percentage value, like how confident the network is, and we'll take from that scores list that class ID, and we'll say that this is confidence. So that's when the confidence threshold is coming into play. So the confidence is bigger than confidence threshold. So like we're not dealing here with, you know, with all the stuff that the network's uncertain about. Like if it's bigger than threshold, then yes, we'll execute it. If it's not, then not today, guys. So we're gonna define the center x, which will be the integer value, because we're now getting the pixels out of it all. We'll get the detection, you know, we'll get, now we're like working with the first 5 guys. So the first guy is the center x. We'll multiply the detection 0 by the frame width. So like this is a percentage value, so we'll multiply, we'll get the pixel value that we're looking for. That the center y, you know, the same logic applies here as well. So nothing really fancy here, just, you know, and width and height, I'll just copy it, because like those things are also percentage values. So we'll get them here. Now left. Now we'll get left. Left, you know, it's almost left value. Like it's almost that value. It's gonna be useful by subtracting the center x minus its width divided in half because it's center, and you know, like this is all intuitive stuff. If not, you can like ponder a bit, which is like good. I'm guessing that there are, you know, maybe confusing things. So now we'll say that class IDs will append here our class ID, which is the object that the network has predicted to be, you know, was confident enough to predict, so that we can then basically the object the network was confident enough to predict. Now we're gonna append the confidences. There we go. There we go. There we go. I'm gonna append boxes. Here we'll put left, dot, width, and height. So I mean, you can kind of smell here, I guess, that, you know, we're getting like all the necessary like stuff to predict our objects now. Like for each detection that it will think that it's confident enough to say that like it's there, we'll put something on our list of, you know, classes IDs, like what's there. Then we'll put there something on a list of confidence, like how confident it is, and then you know, it's bounding box, which is left up, and it's really easy to get, you know, it's right and bottom. We'll do that in a moment. So now we'll do the non-maximum suppression on the boxes. The way I understand this thing here, I think I brought it 2 times for some reason, but the way I understand this thing here is that it's, you know, like, remember when a long time ago I was showing you like the bus picture, and there were like bounding boxes one on top of each other. I think this line basically says that if there are 2 bounding boxes like together, like they're kind of identifying the same thing, like go ahead and just suppress them, like pick the one that's more confident, like don't use them too. That's what tends to happen with YOLO if you just let it slip. So we're gonna do the stuff on, you know, our already predicted boxes from there. So where did we define the non-maximum suppression? Understand? Alright, guys. There we go. Minimize threshold. Great. Now we got this. We're almost there. Now we'll prepare. Like guys, like listen to me. Like if you're still here, like we're getting to the fun stuff, cause like you know what this is? This is us actually drawing the rectangles in OpenCV. So like we're there. We're like almost there. But bear with me just a bit more. When we'll iterate over those Englishes that, you know, it's giving us, so that y is zeros element y box I. This is basically us iterating over like the, you know, like objects and their indices that it start, and like we're iterating over them, and then we're gonna draw the rectangle on our frame for each of them. So we basically got those boxes. Now we're gonna redefine them. Just let me just do this because it's a little bit boring even to me to like write all that stuff, but you know, that's the way it is. So, yep. And then we'll like draw the rectangle for each of those. Now let's go and define the draw prediction, or like rectangles, or the bounding box, or like whatever you want to call it. So now here, once we did that, we're gonna, you know, we're gonna draw our bounding box, the rectangle, and for that we're gonna need like what's the label, and the label is whatever the, like, remember what class ID is? It's the prediction. We'll give it the basically the class that we predicted with that index. We'll give it our confidences of this index with our left, top, and then we'll give it our basically right and bottom. How do we get right? Well, we'll take left and add to that our width, so it's like left plus width. And how do we get bottom? Well, we say let's take our top plus height. So take our top of the image and we basically add up the height here, and so we get like the whole rectangular box here. Now let's define the draw rect function, and we're going to take the class ID that we've specified, and it's going to take the class ID that we've specified, the confidence, our left, our top, our right, and our bottom. Basically all we need. So the fun stuff here, drawing the rectangle with OpenCV rectangle. We'll take our frame where we want to draw the whole thing. First of all, we'll specify the coordinates of our top left, basically this point. I think it's gonna be reversed in the recording, so it's like, you know, you can imagine like it's left. So left, top, and right, bottom. So specify all the necessary coordinates you need here. So next tuple is going to be made of 3 values, which is for the colors. OpenCV works in BGR, so that'll be like 255 blue, 178 of green, and 50 of yellow, which is going to be the nice blue color. Yep, and the line thickness will be 3. And we also want to draw like in the top left side, like what are you actually predicting? Like neural network, like what are you doing? So we're gonna go and say label So next we're gonna, you know, round up to just two digits after the comma. Like we're gonna round up the float of confidence because we don't want that much of that stuff there. We're gonna go like if classes, and we're gonna assert that our class ID that we've predicted is not bigger than the length of our classes, because like guys, we're like something seriously screwed up with out of 80 objects we've got the class of 564. Something's not working right there, and so we'll just format the label with person S, person send, and we're gonna put here classes. Remember our coco.names file and the corresponding class ID and the label. And the label, which is basically our contents here. So now we're just one step away from, guys, thank you like so much for bearing with me if you've gotten to this point, but now it's like just put the text in the top left corner. Just that. All we have left, and we can get the fun stuff. So I'm essentially saying like go to frame, and right there its label, which is its like class, which is like its class, whether it's like person, car, bus, whatever, and its label, which is how confident it is. So laptop essentially saying where we want to put the text. Which font do we want to use, and what size of the font do we want to use? Let's say 2. Color, I'll go with white. And what line thickness do we want to use? So that's it, guys. Like that's it. Now I'm gonna turn the webcam off because I've got only one, and I'm gonna launch it, and finally, like if you've gotten to this point and you were interested in YOLO, you can like give yourself like a giant high five, because guys, like that was not quick and that was not easy, but trust me, once you like understand the skeleton behind this thing, you can really make diamonds out of. So I think everything's working. Like you can really, run it in Python. You can train in your own models, get the CFG files, put them here, like get your own custom models running with this code. You can like do whatever you want with these results. You can, identify the distances like for two people if you can compare the sizes of the bounding box. So like that was painful, and I freaking get it, but you can now do anything you want with YOLO, with your custom trained models. Like, guys, like if that was your like first time with YOLO and you've got something from here, like that was worth it. So now let's get the demo. So there we go, guys, the final demo. Here you can see YOLO like actually running on my CPU, and the FPS is not great. Plus in this code there's a bug with the height. I've added the title kind of saying that please don't do this mistake after me, so hopefully you'll be running the correct version. However, like even with the height back, it's not that bad, and it's clearly that YOLO detects the object. So I wanted to say that if that was useful, if you maybe enjoyed it, even though like I get it, that was long and that was easy, but that was not easy, but hopefully that was useful. You can smash the like button and subscribe and stick around so that you may not miss the following YOLO tutorials that I will release on how to train your own models, how to install Darknet, all the stuff I went through, through maybe weeks of struggling with all the bugs and setting all the things up. So I faced lots of errors, and eventually was able to do it again with the help of many great people who who helped me basically with their advice and experience, so I'm very excited to share that. And I hope that you're having a great day and that you're excited about whatever you are excited about, because being excited is a good thing. So again, let's move a little bit quicker through the demonstration. Where's the horse? So yeah, by the way, Tiny YOLO does about 2 to 3 frames per second, so it's much faster, even though like still not that great. And so I'm guessing that's it, guys. Thank you so much if you've gotten to this point. Like, no matter how you got here, like, I wish you all the best, and yeah, and hope that you're having a great day.